Hey everybody, this is Mr. Aynesworth here, and we're going to get into our second goal here in AP Pre-Calc, okay, here at Great Oak High School. Here, my name is Mr. Aynesworth, as I just said, and we're going to get into graphing untranslated sine and cosine functions in the form of a sine bx and a cosine bx. So take a look at the top in our goal. All right, so let's start off with sine of 2x, and then let's determine what we need to. So we learned in previous lessons that A affects the amplitude and B affects the period. So when we compare, actually let me do this in red. When we compare here, y is equal to A sine of bx, oops, okay, so A sine bx here with what's given here, y equals sine x, we notice that A, which is your amplitude, all right, is 1. It's actually the absolute value of it, so I'm going to write down the absolute value of that, which is 1, okay? We haven't talked about reflections yet, but keep in mind that A can be negative, and when that happens, given the fact that amplitude is always a positive number here, you always take the absolute value if you see a lead coefficient that's negative. But that is your amplitude. Okay, B, what in the world is B? Okay, B is 2 in this case. So if B is 2, that means I have 2 pi divided by 2, which is pi. So my period is pi radians here. And we're given B is 2. Okay, so now how do we graph? Okay, so what we want to do is take a look at the amplitude here. And remember some basics from the sine function. So we're going to label the axes here. We're going to go up 1 and down 1 because we know the amplitude is 1. So I'm going to just make sure you understand that first. That's why I go up 1 and then down 1, because the amplitude is 1. And remember, this is the distance from the wave axis to the max. Okay, so the amplitude in general is equal to the distance, all right, from the wave axis, okay, which some of you guys call the midline, but I call it the wave axis. So midline here, if you guys want to use that terminology. So distance from the wave axis or the midline to the max, okay, or to the min, or either one. Whether you go up or down, it doesn't really matter. Okay, so the high point's 1, the low point's -1. It's basically that. Okay, then you take your period, which happens to be pi in this case, right? Okay, and we go out 4 units, okay, or multiples of 4 units, and we want to divide it into 4 equal parts. Okay, and this is really an important thing. So actually, I want to go out 8 units just to spread things out. So 2 and then 4, 6, 8. I'm going to label that pi. Okay, so key here. Okay, divide the period up into 4 equal parts. So divide, all right, the period into, all right, 4 equal parts. I don't care what the period is, you do this every single time. Okay, so let's highlight that. All right, divide the period up into 4 equal parts. So that's why I went out 8 units, because 8's easily divisible by 4. Or if you wanted to go 4 units, that's fine too. Just go out a multiple of 4 units and then go for it. So if this is pi, then half of that is pi halves, and so on, right here. And so what you want to do is learn from sine. Okay, so remember the sine function. If you're going to take a look at the parent y equals sine x here, when we graph this, okay, it had this up-down cycle. So it went up and hit the axis, and then went down and then back to the axis. And we started on the origin. This is where the parent starts and what the parent looks like, but it has a different period. The period is actually, 2 pi. This one's been compressed, so this is a compression. But we do know that the function starts at the origin. So we start here for sine. Okay, so let's make a little note. Sine starts at the origin. Right there, and then it goes up 1 unit, back to the axis, down 1 unit, and then back to the axis. And then we sketch it. Okay, so it goes up and then down, and you curve it. Okay, it's called a sine wave for a reason. And so the period length right here is pi. Okay, so when B is equal to 2, like it is, that is called a compression. So compression. and that's when b is greater than 1. Okay, so any number greater than 1 will give a compression. So it goes from the period of 2 pi to pi. It compresses it, or shrinks it. It's a compression. So you can say compression, or you can say a shrink. I mean, the period shrinks. You can describe it more than one way. So remember, the parent function has a period of 2 pi. Okay, period of 2 pi. You shrink it or you compress it. It brings it in. Okay, and you have a shorter wavelength. Okay. Okay. Number 2. I'll do a few of them. I'm not going to do all of these, but I will do a few. Okay, and then hopefully after a few, you kind of get the idea. All right, so next one, number 2. We have 4 cosine of 2x right here. So a is 4. So this is a and this is b here. And b is 2, so we have a change in amplitude and also a change in the period here. So the amplitude is 4, which means I got to go up 4, down 4. So I got to scale the axes, go up 4, down 4, and understand that this represents your amplitude right here. And then b is 2. So just like the other one here, if b is equal to 2, that means we have 2 pi divided by 2, which means the period is length pi again. Okay, so now we also have a shrink, we have a compression. Okay, so it's compressed. Okay, so what do I want to do? I want to go out, just like the other one here, I want to go out pi radians and then divide it up into 4 units. Okay, so 1, 2, 3, 4 equal parts. Okay, and then I go for it. Now, this is cosine. Cosine, if you go back to basics and take a look at your parent function, doesn't start on the the origin. It starts up 1 unit because the amplitude is 1. So it starts up here, and then it goes out. It goes down, and then back up, and then to a maximum here, and again it stops at 2 pi. So again, you take this and you start at the y-intercept here. So cosine starts there at 1, but now because we have a new amplitude, we don't start at 1, we start at 4. Okay, and then it hits the wave axis, and then at pi halves, it goes down to -4, and then back up to the wave axis, and then back up to a maximum. So it starts at a maximum, and it ends at a maximum with a length of pi this time, because we have a new period length. So here, p is equal to pi, the period length. And then you sketch. So here we go. So it's going to be decreasing. All right. It's going to make sure you curve it here. Don't make it V-shaped. That'd be bad. And then curve it here. And that is 1 period of this function right here. 1 period only. Notice the directions up. Well, it doesn't say graph for 1 period, but I'm only graphing for 1 period only. Okay. Okay, so that's that one. Let's do another one. In fact, I'll do 2 more, and then you guys can do the rest. Okay, so in fact, if you want to, you can press pause right here, give it a shot, and then press play, and then kind of do a pause and play routine where you check your work as you go. So pause the video, actually, and then press play when you're ready. Okay, so now I assume that you've done it. Okay, so here we go. So a is 3, b is 1/2, and that means that we have 2 pi divided by 1/2. That's the same thing as 2 pi divided, times the reciprocal 1/2, which is 2. So here now, the period now is 4 pi. Okay, so this is a stretch. It's expanded. Okay, so the period now goes from 2 pi to 4 pi. So now I'm going to go out again. I'm going to label the axes here. So let's say this is pi, 2 pi, 3 pi. All right, and go out to 4 pi. Notice I took the period of 4 pi and divided it up into 4 equal parts. Okay, you always do that. No matter what the period length is, you divide it up into 4 equal parts. As I said in the very beginning, in the key, divide the period into 4 equal parts, and then you can start your graphing. Okay, but you have to label the amplitude here. So up 3, down 3. And remember, this distance above the midline or the wave axis is called the amplitude. Okay, so from this point, okay, here we go. Dun, dun, dun. Okay, so starting up here, cosine starts here at a max. You always start at a max on the cosine function. All right, and it goes down to the axis, down to a minimum, back to the axis, and then back to a max. Okay, and then you curve it. So here we go. You got to put the sound effects in. There we go. All right, and you have one cycle or one period of this function, 3 cosine of 1/2 x. All right, there we go. That's how the game is played, my friends. Okay, so now, last one, and then you guys do the rest here. All right, because you got to try some on your own. And then you can check my instructor's notes for the rest. Okay, so for this one here, okay, A is 4 and B is 2. Okay, so we have amplitude of 4, B is 2. That means the period is 2 pi divided by 2, or simply pi. So this is a compression. Or a shrink, okay? Some people call it shrink. So you use whatever terminology you like. So I'm going to go up 4, down 4. Then I have to go out pi radians here. Uh-oh. Let's see here. 1, 4. Maybe I forgot to change that function. That's too bad. I was hoping to change the function, but it's okay. I'm going to continue here. 4 cosine of 2x. Oh, you know what? That is the same as number 2. I got to change this. I'm going to change that right now. So just get out your eraser here. Okay, I'm going to change it. This is a repeat here. So now the new number 4. So y is equal to 1/2 times cosine of 1/3 x. Okay. Yeah, that was a little typo there, guys. I had to change the function right there. Okay, here we go. So now what do we have? We have A is 1/2 and B is 1/3. So how does this change? So now the amplitude is a 1/2. Remember, this is the amplitude. So now I'm going to rescale the x-axis here. So I'm going to go up 1. I'm going to label that 1 and then down 1. I'm going to do it like this so that 1/2 is right here. So 1/2 and then negative 1/2. Stretch it out a little bit vertically so we can like plot these points easily. You're going to label the axes however you like. Okay. Now if B is 1/3, I have 2 pi divided by 1/3. That means I have 2 pi times the reciprocal of 1/3, which is 3. So now my period is 6 pi. So this thing has been stretched out. Okay? It went from 2 pi to 6 pi. Holy cow. So here we go. So I have to label. So I'll go, let's see here. So, you could do it however you like. So, 2 pi. Let's see. We want to divide it into 3 or 4 equal parts. So 2, 4, 6, 8. Okay, so label this 6 pi. Half of that is 3 pi. 1/2 the distance, so that should be 3 pi, because half of 6 pi is 3 pi. And then half of 3 pi is 3 pi halves. Okay, so now we start graphing. So here we go. Now this is a cosine function with an amplitude of 1/2, so it starts here. Start at max, as I said before. And my previous one right here. So here, the maximum is going to be at 1/2 on the y-axis, and then it goes down to the axis, and then down 1/2, back to the axis, and then up 1/2, and then you curve it. Oh, I forgot to put the sound effects in. Sorry, guys. Okay, so there you go. All right, and there is your function, 1/2 cosine of 1/3 x. There we go. And that, my friends, is how it's done. So after this right here, you're going to check with instructor's notes, because I'm going to stop the video here. And after all this, you're going to check with my instructor's notes, okay, in Canvas. And you guys know where they are, but I'm going to go and show you. So here, at the very bottom, you'll see it right here at the bottom. It says Unit 6 Instructor's Notes. Ooh, look at that. You just open that puppy up, and there you go. You get all your answers. Okay, so back to the lesson here. So this was the second goal here, where you have to actually graph the function and determine the amplitude, the period, and the b, which is your coefficient of x. So this is a horizontal transformation. And remember, whenever you're multiplying x by something or adding x to something, we're talking about a horizontal transformation here. And we'll shift it later on in the next few lessons here. But this is it. All right, give it your best, finish your work, check with my instructor's notes, and I will see you in class. You guys make yourself proud, and I'll see you then.